it recorded all the other 40 minutes that happened.
Okay, I think I joined.
Yep.
Then I do share screen, right? Start what? Yes.
Yeah, we can see it.
Oh, that's cool. That's
All
cool.
right.
This is nice.
Great.
So let's see. Here we go. Okay. So let's see. Okay, so I think so FTD is about understanding the whole system, right? So like a good idea would be, so we can start with like the overview in the beginning, like with an all electrical part. Like we have in this team we have software, energy systems, electronics, and yeah, that's it, right? And then here we go, high voltage, low voltage, and then this goes PCB sensors, and then software. How many subsystems does software have?
3.
Infrastructures, right?
Infrastructure, comms, and control.
Comms and control. And this is all electrical, let's say. Okay, so one thing we can do is maybe start describing, like giving an overview of what the point is, I mean, or what the function of the electrical system is in the pod. Like we describe this structure briefly, so that we let the reader know what we will be talking about. So like brief discussion of the structure.
Yeah, like a small executive summary.
Yeah, like maybe some diagrams how everything are connected. Like we have software.
I think just explaining what each system connects with one another and their role.
From like a hierarchical, like very high level overview.
Exactly.
Like energy here.
Yeah, we can do a simple block diagram.
So like software, does software have like any direct connection to energy systems?
Yeah.
For sensing it does.
We have temperature sensor. Well, it's not necessarily a sensor, but yeah, we give them temperature and the battery state of health information.
Okay, so sensory input output. So yeah, sort of a high level block diagram, and then we can dive deeper into discussing each subsystem. So what would you say is the most which is the system that would be the most high level, or that gives the most information? Like we can start from the top down or from the bottom up.
Well, it depends. Do you want to talk about it from a power distribution perspective, or do you want to talk about it from a information distribution perspective?
So yeah, that's okay.
Let's think of it from like how like what the electronic system was made for, right? It was for powering the pod and controlling it, and providing information outside the pod. Just those 3 things. So I think from there, like you can either start with, all right, to control the pod. Where's the background noise coming from? Yeah, so like to control the pod, we need to do blank, and this is where we're going to get our power from, and this is how we're going to send out the information outside the pod, or just any arrangements of the 3.
Actually,
It was-
starting from that control perspective and with electronics being like the heart of the control systems is, I think that's a good way to go because it shows them, okay, this is the very root of it. This is how we are controlling the pod.
Yeah, so like we can start from a hardware level and then abstract it out, up basically, like moving into the software. So
We
I
could-
think,
Mhm.
like, sorry.
I mean, we could also do it the other way from software, like how would a person interacting with the pod control it? But I like the electronics way.
So yeah, what's more intuitive to you, like starting from the hardware level and moving into the software, or
I,
from
I think it makes more sense to go hardware to software because like you can't tell them, okay, we're gonna get data from this sensor and this is how the software will function and make sure that the control works correctly when they don't know that sensor exists in the first place.
Yeah, I think that's a good point. I think so too. And even when you're learning this stuff, like let's say computer networks or something that involves both the physical infrastructure and the software, you usually start by understanding first what the physical parts are, how they function, and then you justify the code, right? Or you give the context to the software. So yeah, I think that's a good flow. So from electronics, we can flow into like a software. But I think before we talk about electronics, maybe we can talk about energy systems.
Yeah, I was gonna say, I think it might make more sense because that's the most like basic from an information processing standpoint. It does one thing and it provides power.
And
Yeah.
something we can do is when we talk about maybe when energy systems talks about like the sensory output, you can move that section to maybe software if software is getting the inputs from there or something. Like we can try to connect them by by referencing different sections.
Exactly. So I think for energy systems, it would just be, oh, we've got temperature sensors and all these safety features included, and then refer to section whatever it is
Yes.
for more in-depth explanation of how the safety controls are triggered.
Yeah, and maybe you can put those inside the electronics in the electronic section, just so
Yeah,
it makes more sense.
we go through all how each sensor works and they're like the info about it, what like what you expect from it, what you don't expect from it, like what is it for, whatever.
Mhm.
And then in there, because we're gonna do testing now, we're gonna add all the testing requirements. So we can just add like the testing requirements for the battery as
Mhm.
well.
That makes sense.
Yeah, this would be only related to the temperature stuff. The remaining like other battery stuff would be in energy systems.
Yeah, and I think we could just give a super high level overview of how this testing works and why we're using these tests.
Yeah. So
Is sorry, quick question. Are inverters and stuff going to be in our section, or is the motor guys going to talk about it?
So inverter is our section, and I think we have to talk about the motor too, because when I talked to Javad, he had is not much idea on how it worked.
Okay.
They knew about how it worked from a mechanical standpoint, but in terms of how the power from the inverter actually turns the motor, the axial flux and everything, it's not something they looked into at all. They just
Okay.
picked a motor that had the torque they needed.
Yeah, I mean that's kind of how I would do too. Okay.
Yeah,
now
in that
just-
case,
yeah.
um,
Sorry, yeah, continue.
um, okay, energy systems. Okay, like you start reading it, you get the idea that okay, this is how all electrical system works on this pod. This is how it's supposed to work. And you read energy, you get the idea. Okay, this is how power is gonna be delivered. They talked about high voltage stuff. Now they're good. Now they talk about okay, the inverter itself,
Yes, and then the low voltage.
the low voltage, and then you go into the actual control side and the infrastructure of the electronics. You figure out how everything's tested, all the hardware testing, whatever. Then you go into software. Software talks about the software side of control, the comms throughout the pod, the comms outside the pod, any infrastructure that they have set up. And I think that covers like a general overview of how this would be going.
Yeah, so
Yeah.
let me just like do like a small overview of the whole system. We have this thing, and then this flows into the first part of would be high voltage.
Yep.
And just one thing, what's inside high voltage? What are you guys talking about here? I don't want to get into a lot of details, but just like a brief.
The battery.
The battery
Yeah.
and a BMS.
Okay. And
Yeah.
yeah, so the sensors are in here, right? So here you reference.
Do you want to talk about current sensor at this point?
Sorry.
I think you can just like just reference it that we have a sensor. It's elaborated more on in this section.
Yes.
Yeah.
So that they know that when they read about like the battery sensor, when they go into electronics, and or from this part they can just skip to that page and read about that sensor, or they can
Mhm.
read later on. But sort of knowing that it's connected at that point. You know what I'm
Mhm.
saying?
Yeah. Yeah. I think
So-
just telling the reader what the function does is good enough, and then if they want more information, they can look into the appendix or
Yeah,
Exactly.
the
I
electronics.
can reference the appendix.
Or you can just appendix it
Yeah,
if it's not very important.
like
Then we move.
there is a like a whole hardware and software side to the high voltage battery, control BMS controller, but those like I will talk about it within the battery itself. Like I will talk about those in detail there.
Yeah, that's fine. That's fine.
Mhm.
Because like in reality, okay, like I don't know anything that's happening on that side.
Yeah,
You guys
yeah.
have always been doing that, so talk about it. That's your own thing.
Yeah,
And keep it that way.
like it's its own separate system, and that's a good way to keep it.
Yeah.
So yeah, you can decide to talk or appendix anything that's not
Yeah.
directly related to like energies.
Yeah.
And then we move into inverter and the motor.
One thing I do have a concern about is that I was reading somewhere in the FDD that we need some sort of like energy sink or drain method.
Uh,
What? What do you mean by that?
Like to discharge everything.
Yeah, like in like
Look.
cars, the body is the ground, for example. I don't know how we would exactly implement it with this, considering the structure of it is made of carbon fiber tubes.
no, but the chassis is metal, I think, right?
Like the
Like
tube,
the
black
metallic shit.
No, the baseboard is metal. The shell
Yeah.
might not be metal.
the shell is not.
Yeah, like that'd be hard to make that through metal.
I
It
don't
just
really.
costs too much.
Mhm.
So
And I don't think.
Yeah.
Honestly, for now, not a problem, but just keep it in the back of our minds. I think Rakib was trying to talk about some sort of like discharge method that he had in mind, but we never got into it because it was not a very big important issue at the time.
Okay, do you want to just add that like a side note here because we'll probably slip our minds.
Yeah.
Like, just
Like if
charge
anybody
method.
has any ideas at any point, I'd really appreciate that. Like the only way I could think of it is like ground everything to the negative terminal of the battery, because that's kind of your ground.
That's how it should be done.
Is that how it should be done?
But
I don't think grounding to the chassis would be a good idea, especially if that means you drop the positive onto the chassis and accidentally spark it.
Yeah.
Another thing is though, like, does like you don't want to build up a charge compared to the outside world, right? Because if you're moving through open air, that's what's gonna happen. You're gonna build up a charge, right? So we gotta think about that too. But I think we can talk about it later. Like, let's stick with the goal right now.
Yeah. And I don't know. I can't find it either. I'm trying to look at it and find it, but we'll worry
No
about that
worries.
later.
Okay, so
Okay, so, high
or
voltage.
continue.
We move from high voltage to inverter, and the discussion and a brief discussion of how the inverter basically controls the motor, right?
Yeah, and then here we can say how the inverter is controlled by electronics and software, but we'll talk about that in more detail.
Yeah.
I think an
Yeah.
entire dedicated section at the very end.
You can reference it or appendix it if.
Yeah.
Yeah, I think for this, let's reference electronics and
Yeah.
software to show the integration.
Because electronics will talk about the CAN bus interface, so it's worth referencing.
Mhm.
And software is writing the code for that, right? Okay.
Yeah, software is a control code. We do the communication code to Canvas.
Low voltage. So at the low voltage part, this basically what the layout is and how everything is powering the sensors and the computers, right? Yes.
Yeah, sorry,
Yeah.
sorry, my thing was muted. It is the low voltage is there to provide power for all the sensors and the controllers, the Odroid, and everything.
Okay.
Then we go to electronics, and we start with schematic, or let's say physical layout.
Yeah, like let's just we can explain like yeah, the sensors. Just go into like the sensor stuff.
Okay, yeah. Like talk about the sensors first.
Yeah, and then we can explain like the layout of like when you talk about the sensors, you can talk about where each sensor is, what the point of it is, and then I'm assuming like every other team will refer to like the document, like the wherever the sensor is, a section of that. So let's say like braking refers to the pressure sensor, they'll just refer to whatever section we tell them to.
Okay.
And then from there, physical, and then PCB, and so on.
This is the thing though. Before we talk about each sensor, don't you want to have like an overview of the whole system, like how everything is connected and like something like that? Like a circuit diagram of the system, and then each sensor is described in like detail. You know what I'm saying?
What I'm talking about is what we did for the last report. Last report, all of that was a part of the sensors because it explains like how the sensors work together and how they're integrated to the rest of the system. Like that diagram and all of that was a part of like the sensor section per se.
Oh, okay. Okay, so like we're saying the same thing. You're just saying that this belongs like inside the sensor.
Yeah, exactly. Because that's a start of it.
Okay. So yeah, sensors. Well, I mean, if we have sensors, then we just, because you're like summing up everything here, right? What else do you want to talk about?
Oh, so like, all right, you know what? Let's do like this then. Sensors background. Like we'll go we'll break it down really deep then. Sensors background information. There should be like a diagram or something. Okay.
Yeah, sensors diagrams and like, or let's say sensor details, right?
I want to say details, just an overview. Okay, electronics overview.
Okay.
Just put it like that. Electronics overview.
Yeah, that makes sense.
Okay. Now that you do the overview, then we can now talk about specific sensors and components, a part of the electronic system.
And okay, so these are part of electronics.
Yep. So like over here, this includes like any and everything. So I mean like the braking solenoid valve. Sure. Like we'll talk about it here. The canvas module we talked about here. Anything that involves any electronics thing what we talked about here and expanded upon on the electronic side, just in case it hasn't been done before. And even then, this one section accumulates like everything.
Yeah,
right?
and then we can move to like the sensors from other systems, right? Such as like high voltage.
Yep.
Or whatever.
Yep.
Okay, and yeah. Then after this is done, you want to move into like the software?
No, I was thinking let's break it down into the physical part, because then software can easily go into their communication system by referring to how we broke it down physically and how they have to communicate because of physical like distributions.
You mean like the PCB and
Yeah.
the diagrams?
Exactly.
Okay, maybe this is what I don't understand. How? Okay, and then when we talk about the software, because I'm not sure how like software takes all of this and basically translates into their code and stuff. Okay, so let's say physical layout.
This includes PCB structure and how the PCBs are divided, etc.
Yeah, PCB. Just like PCB structure components. And like
your wiring diagrams, all of that,
interfaces. Okay, I guess this makes sense because we're telling them how it is connected to like the software part, right?
Yeah.
And then we move into overview of software. So, is it better to start with the controls or the communication part?
Communications.
Okay.
So if you want us to write like a general overview of the software, you can just add a note like the main objective of the software system overall is to accomplish 3 goals, which is delegated to our 3 subsystems. So we want to have a high modular control. We want to have good low-level communication system design, and we also want to have visualization of the system.
Or do you want to write this as bullet points on the side like you did for everything else?
Yes.
Yeah. So I'll
can you just like give me a minute so I can get the charger? I think.
Oh.
Okay.
Just 1 minute. Sorry about this.
Dave, so what's the difference between like communication and infrastructure? Like, if I remember correctly, infrastructure was the external stuff, like
Yeah.
the external views and whatnot, and the communication is internal.
Communications is the embedded aspect of software. So in the same way that you have, and you're right that remember when we were discussing the document in December, and I said we're going to start with communication anyway, because it flows directly from electronics from the PCBs, because we need those. So from PCBs we use that, and that will be the pure hardware of the communication system. We'll be taking those hardware and we'll be coding it, setting it up, testing the data streams and everything, making sure that there's a network and there's data sharing, essentially. So that's what communication is about. We want to be able to, excuse me, I have my notes right here. Right. So communications is about between the sensors and the state estimator. You want to be able to have direct control, well, not really control. You want to be able to have good data sharing between the pod and the control center. And the rest of so essentially the communication system brings together all of the active components. So like we can see that the battery systems and the electronics and the brakes and the motors are all talking to each other. We want to be able to facilitate that. The infrastructure, on the other hand, is about visualization. So we have a control panel interface on a laptop. You can enable command of the pod because you need to be able to tell the pod whether to start driving or not. So to launch, if there's a manual override for emergency stuff, you can do that from the infrastructure side. and you will be able to visualize all of the data streams. So that's why they have a so when Arnav was talking about the dashboard and the control panel, you can see the battery levels, you can see the speed, you can see the distance covered, you can see the temperature and the pressure and whatnot. You will be able to see what state the pod is in, and you will be able to see a log of every single thing that goes on in the pod. So for instance, if the pod changes state to fail, then you will see everything that led up to that failure, if that makes sense.
Okay.
So,
Cool.
so every decision that the pod makes, whether it, if you lose connections to Arduino 1, then we will tell you that we lost connection to Arduino 1. And so we have like I think we have to ask who has a two-dimensional schematic of the pod?
I think we can go into that detail like
Yeah.
later.
Yeah.
What I was referring to was so after you do communication, right? What do you think makes more sense to do controls after that or do infrastructure after that?
You want to do controls after that, because from the communication, we have diagrams for every one of our subsystem to show from a high level how the data flows. So in our communications diagram, and that's probably the biggest one, you will see all of the Arduinos, you will see all of the sensors, and you will see all of the channels they are connected to, and how they are funneled into the control system. From the control system, the diagram will show you where that information goes into the controller and how it's connected to the infrastructure. The infrastructure is connected via a socket from the controller. So all the data flows like through that tunnel in terms of packets. And then it takes that packet, demultiplexes it into different classes, and that makes it easier to put on the screen, if that makes sense.
Yep. Okay. Cool. Horst, you're back?
Yeah, sorry.
No
Something
worries,
really stupid on my end happened. I went to grab the charger and I unplugged the internet. So everything was like down for a few minutes. But yeah.
Okay.
Sorry
No
about
worries.
Okay, so basically I'll just rehash everything I just said.
that. I'm really sorry, Dave.
It's fine. Tell me
So
when you're.
what do you want to add on the communication part?
Oh no, I was just gonna say, like, just like every other subsystem with the electrical, you can have. I assume everyone's gonna put a general overview of their own subsystem.
Yes.
Yep.
Right. So for the overview of software, you can just put these bullet notes to the side. So the main objective of the software are three big ones connected to each subsystem. The main objective is to provide highly modular control. You want to have low-level communication system design to connect all of the active components of the pod. And you want to have, and you also want to have a control panel interface to visualize all systems and data streams, as well as to provide, sorry, let's get my notes, as well as to enable command.
Can you guys see my screen?
Yep. It's all good. We see you writing everything.
Oh, okay. Sorry, what was the third point again? I missed the first point.
So the general idea is to also provide an interface that allows you to enable command over the pod, and
I see.
And
the front end that you were talking about, right?
Yeah, the front end gives you command, and the back end ensures visualization and of data streams.
Okay.
Okay, cool. Yeah. So then we move into communication side.
Right. So for you can just put the big ones down first, and then we can go into the little details. So from communications, we'll go into control, and then from control, we'll go into infrastructure. So again, with this document, you don't want to give them way too much detail.
Yeah.
So we have a diagram, and it's not too detailed, but it has just enough for you to know exactly how it works. We have a diagram for every single subsystem. So we have a diagram for communications, control, and infrastructure.
Yes,
So the last thing that you guys talk about in electronics is the PCB layout and the wirings and whatnot. So in the communications diagram, we take that and we have the Arduinos, we have the sensors attached to the Arduinos because you gave us the wiring, so we know what goes where.
Yeah.
But then we show the flow of data. So in the communications, we will show the flow of data. We will show how this data is organized into channels and how these channels are all publishing to one master computer, and that's the Odroid. And we will also show, yeah, sorry, I'm going too fast.
Channel, I'm gonna say this.
So the channel is a publish, subscribe, inter-process communication model. So Arduino's publish and Odroid subscribes.
Okay.
And we're going to show, so we're going to show how the data flows and why the communication system brings the active components together. So for example, we will know what happens in the brakes, in the batteries, the motors, the inverter. I think that's something we all have to talk about later on, and whatnot. So from there, it'll be easy to flow to control, because all the data goes straight, because with the publish subscribe model, all of the data publishes to the Odroid. So in the control, the diagram is essentially the Odroid and the controller, or the state machine.
Okay, so
yeah, so the Odroid, the state machine, and we're going to show within the Odroid we have like the health monitor, we have the estimators, and we're going to be using that to predict what the next states of the pod should be. So for instance, if we lose comms with a critical system like the motor, for instance, or the brakes, then in the controller, it should make a decision that probably it's not safe to drive. So then it should go into a particular state like emergency or something. But that's usually the worst case. And in the normal case, usually we just collect the data and we ensure that there's comms. And if there's no comms, then we want to be aware of that, so we can trace back what happens. From the control, we have a socket, a C++ socket to the infrastructure. So then we go into, so when you write that socket, we go into infrastructure now.
Okay, I'll just use this as maybe as a connection here.
Yeah.
Is everything?
It's
I don't know. I'm hearing some sounds. Okay.
It's all connected. It's all connected. So communication goes straight to control. Control goes to the infrastructure. So from after control takes all of the data and it bundles it into a package, it sends it like that socket or a tunnel to the infrastructure. So the infrastructure now takes that. So we have a diagram, of course. And it's divided into the backend and the front end module.
Okay. All right. Okay. Like what we're doing is good. And like we can elaborate more and more into like these details.
Yeah. No, I'm just telling you like this is how it's going to be structured, and
and
that's it.
That's good. That's good. And we can like add more on this like in a bit. I just had like one thing I wanted to bring up. So if you scroll up a little bit.
Yes. At what point?
So you see like in the high voltage, we have the inverter and motor control stuff. So that's going to be referenced inside of, from energy systems, that's going to be referenced inside of electronics when it comes to like the sensing part, right? Because that's a component that we're going to talk about, and it will be involved in our side. And then on
can you
I'm sorry.
Hello?
Can you hear me well, or is it like me?
We can hear you.
Can you guys hear me?
Because
yep, we can hear both of you.
Okay, because I was I don't know, everyone was cutting off a bit.
Okay.
We can hear both of you.
Okay, so is this the right spot?
Yeah, this is fine. Okay, the point was so energy systems introduces inverter motor, right? And then they're going to explain like the energy side of it, how it's powered and stuff like that. And then when it comes to like the actual electronics is going to be responsible for the actual like the hardware that connects from the Arduinos to the actual inverter, right? Electronics is going to cover that. That's cool. We're going to talk about how it's placed on PCB, like number 1 or whatever it is. And then software comes in, and then software needs to explain like how, like their side of it. So energy introduces whatever.
Wait, 1 second.
Electronics is gonna.
So I think, I don't know, I'm having some like Wi-Fi issues with the laptop, I guess. So I'm just connecting now through my phone. I can hear you better now. Can you just please repeat that again?
Okay. Energy systems introduces the power side of the motor / inverter. Electronics covers the hardware that we use to connect to it and control it. Software needs to cover specifically like how they're gonna control the inverter and motor, and I get that we've designed it in a general sense of that we have states, state machines, and estimators that are used to control it. But we need to talk about specifically that, okay, you know what? This inverter needs this thing, and it uses these states. This is a state diagram that is used to convert. This is what we're gonna do exactly, and so on.
Yeah, we need to tie everything back to electronics being a supporting function of getting the pod to move.
Exactly, but like
And what's important with the inverter is that we need to ensure, because the inverter has its own state machine, right? So from our end, we need to ensure that we can synchronize the inverter with the software.
exactly, and
Right.
like we're going right now. I see like software is going into like okay, any of these sections we could talk about it for hours on it. Let's be honest here. Like everyone here knows that like they're so complicated that like you can talk about it for literally hours and hours about like how about their design and whatever. Well, I think a big part of like control needs to be like the specific like things that we're doing for the inverter and motor.
Yeah.
Like we have all these monitors and estimators, and we're using C++ sockets and stuff. That's beautiful, but we need to have something there that's specifically just for the inverter.
Yeah,
That,
and we got to keep our audience in mind too. Like,
yeah,
the people judging this are smart, I'm sure, but they're not as involved, obviously, in the design of the things as we are. So, um, keeping the audience in mind, and they just want to know, is this safe? And will you die if we run this? And the answer is no. And why is it no? Because we have a properly sized inverter that energy systems, control powers. We have the proper electronics to control that inverter, and we have a really great integrated software solution that can manage all that. So I think that's kind of the things that we want to go. I don't think necessarily that the judge or the EHW folks really care about the nitty gritty. It's just, is it safe, and will they be liable if anyone dies?
Yeah, they want to know if it's safe and how it safe and why is it safe. And June explained that like perfectly.
one thing that we could possibly do is like Orsa's writing move details to the appendix, or even this is what I've been thinking for a while is like energy systems can go over like just high voltage, low voltage, and electronics can go over like the like each system talks about their stuff and like in general their
Mhm.
stuff, and then what we do is we talk about the motor and inverter together, and then whenever anything else is referred, to say go back to that section to learn about that, go back to this to learn about that, and the inverter is just it references everything else, but in it like we could have like a page or 2 pages about it, and that they explain like very well how it's going to be controlled, the safety aspects to it, the testing of it, and everything else that's required for it, and it's all put together, right? So it's really easy to understand that, okay, this is what they have in mind, instead of going through like, because from the start of energy to the end of software, there's gonna be like 50 to 80 pages.
It's gonna be a slog. They're gonna hate
Yeah,
us after finishing this.
yeah, like so maybe it's like, and we need to have these details. I'm not saying not have these details. Like some of them you need to, because they'll question it. But maybe for the inverter, we could just take it out and have like just an inverter section where you have energy, you have the hardware, then you have the software, and then you just have the inverter. Or you have the inverter first, and then you say to learn about whatever refer to it.
Yeah, I mean, if you frame it like that, I think having the inverter up front and foremost and say, okay, this is what's actually powering the rest of the car. These are all the various safety features and whatnot, and then this is how, and then high voltage powers the inverter, low voltage distributes the energy necessary to control the electronics that control in the inverter, and then software just integrates everything together. So yeah, I agree with Ramon, the fact that, you know, maybe we should kind of place the inverter first and foremost, because I think that's like the piece that connects us with the rest of the pod.
Like I like that's I agree with Jun because that's literally what I said. But do you guys have any other ideas or anything else? Because at the end of the day, like they're looking at us and trying to point out that, you know what, I can't let them in here because this reason. This is something they forgot about. So we got to think of it like that, and we also need to make sure it's easy to read while proving that we're safe.
Yep.
I think after reading week could have a good brainstorming session where we try to get everybody in the team and kind of do what Dave did. We have breakout rooms with one of us in each of them, and just take a section and get the electrical team members to talk, to read through it and point out, try to come up with ideas and point out flaws within these key sections, like ways in which they could nitpick it and prod.
Yeah.
Yeah, that's a great idea.
Because that's like, we can talk all day, right? And we understand the system really well, but at the end of the day, we're trying to explain the system to someone who doesn't know anything about our design. And that's the key thing, to communicate to someone who has never seen it before how it's safe, why it's safe, what it does.
Yeah, in terms of the FTD, do they ask for like for us to cut down on design and focus more on testing, or is it just like the same as last time except more on testing?
It's literally the same as last time, and then there's just more bullet points which just ask for testing.
Okay, cool. So just make fatter safety sections.
Yeah, and like, how does your testing like ensure that this thing is safe? You know?
Yeah.
Well, from our point of view, we have already began working on that. So we, I mean, majority of the things I've said before are already in the last document. So essentially, what we're doing is just making that testing section fatter.
Yeah. That's good.
So I'm not sure what else we can add though. If you guys have any suggestions.
Okay, how about this? So, like this structure sort of resembles what we had last time, except we just pivoted like what we're trying to, the message we're trying to send, right? So, like, what if we just like just start getting everyone to write their tests, right? And then like we just have them read the last section, because how I see it is you can just copy like everything after energy systems from the last report, plug it into here, and then I might change a couple of things, but at the end of the day, like everyone's just adding some more tests.
Do they require like the actual tests, or do they want us to discuss the tests?
The actual tests, like how are you testing this, like the actual process.
Okay, so if we're testing with using a Simulink model, they want to see the Simulink model.
Yeah.
Yeah.
I would say if you want to go in super detail about the actual test itself, you can write it in the appendix, but talk about your experimental procedure, the theory behind it, and what is your what's the rationale, like this is what this tests because of this.
Yeah, but that was the direction we were going with. Because I don't think we can get a Simulink model done in 2 weeks.
Oh, you don't have to have the test done.
Yeah,
Okay.
yeah, the idea of the test.
Okay, well, yeah, no, that's what I'm saying. We can go into detail on what the tests we're doing, why we're doing it, and what it's going to prove, but we're not going to have it like a full Simulink model done for them.
Yeah, like it may be helpful to talk about like this is what this test aims to do, and this is the behavior we would expect. We want it to do this, this, this.
Okay. Okay. Well, that's fine enough for me.
Are you guys making a Simulink model of the inverter?
So what we aim to do by sometime in the end of March is we want to create a Simulink model of the control system itself. We can get data in real time, so we can see how we can simulate how the pod will behave depending on the decisions, right? So we're going to assume that the pod behaves what the controller says it should. We just want to make sure that the controller does what is expected of it.
Oh yeah, okay.
Yeah. Okay. Just takeaways for for everyone else that's gonna actually write this report. Do you guys think it's because okay, this is the main reason I kind of wanted this. Is like if you give everyone like a report that they're like, okay, you know what, this is decently long, or this is my little thing I gotta fill in there, then that's gonna get them going to like write about that, whatever their thing is, right? Instead of right now, like it's just okay, you come up with some test. Right? Like show them their role in the massive like project work we're doing.
And whichever one is faster.
Well, do you want to go like the way where we're like, provide proof that this sensor is gonna work under like these conditions and they can do however they want it, or do we tell them, okay, like write these many tests or something like more?
In terms of the test, is just point of failure analysis. That's all it is, right? You analyze your point of failures, but I'm just speaking in terms of like to get them going, because like we wrote 80%, and to get 80% done, you have to knock out the integration, because like near the end that's what kind of like had us working until the last day. Like I think Kiki remembers this, but like that's the part that really gets you.
Yeah, the integration thing takes the longest, but it can only happen after everything else is done. But the integration is best done by a few people. The rest of it is best done by a lot of people at the same time.
Yeah, so like I was just thinking that like let's just have like one doc where everyone just, it doesn't have to be like all three systems, but just a doc where each person writes their thing, and then maybe we can do all the integration, but let's do that on like an ongoing basis, so we don't just kill each other when it comes to like what these things do.
Like work on the integration on an ongoing basis.
Yeah.
But yeah, and be strict about the deadline, especially because it doesn't take very long. But if everyone's doing it, all those individual smaller sections to build up all this stuff.
I think let's give them like a sample of just one thing. Like it could be even a small component that like this is like the point of failure analysis. These are the tests that we came up with, and this is why the tests are justified, and this is why it'll prove that this is safe to operate. Just like we do that for one system or just one component, and then we can just give that to everyone as like a sample, and they can just do the same thing with their own.
Yeah, sounds good. So is this structure adequate? Because I know, Oris, you wanted like a template for everyone to follow, but I think that's going to be like the template that I was going to go with was the EHW. Like I'm just going to put those questions onto like the requirements for this FDD, put it onto a document for each of my sub teams, then they fill it out. And then I would string all those together to make one. In terms of like an actual.
I think what we have right now is like this is what I was looking for.
Okay, yeah, I wasn't sure what exactly you wanted. That's where the confusion was.
Yeah, no, this makes sense now because we know what the flow is, and we kind of have that idea. Like within each of these boxes, we talk about the system, and then the testing procedure and how it proves that it's safe, right? And
Mhm.
sort of kind of the first part was done even in the last document. So right now we might make some changes and just add the testing part, as you said.
Yeah.
That's the idea, right?
Yeah. I like this. I like this a lot because this structure shows us the direction that we need to go. It tells us like what we have to do.
And
Okay.
this way we can even work on one document, and you know, when if people are confused about something, they can just go to different sections and read about it. And I think it makes integration easier as well, right?
It will be helpful to post this onto our all electrical and somehow like just try to highlight it to all the members. Like, okay, this is the structure of the document, so you understand the expectations. And I think next meeting we tell them that like
Yeah.
next
Yeah,
meeting
for sure. I can do that. Yeah.
Yeah, let's also have like a sample of just like the testing stuff, like what we expect, and then they can just fill like do the same thing with their component, whatever it is.
Yeah.
Yeah, for sure, for sure.
Okay. I think this covers like the structure of the FTD.
Yeah. And I
Alright.
think it allows us to have good integration on the electrical teams, especially with the mechanical side.
Okay. I just want to. I think if everyone's okay with this continuing for a little bit more, let's shift the focus with the software shipping and buying stuff.
Oh my god, I almost forgot about that.
Yeah, I know. Whatever.
All right, so Dave, actually,
what
yeah.
what do you need?
Dave, you're muted.
Maybe I just went to get something for a moment.
Yeah.
Okay.
Hello?
Yep.
Yeah, sorry. Ow. Can you repeat what happened?
We're shifting.
What do you need?
Yeah.
Oh, right. I think I gave you and Oresta the list. Ow.
Okay, so all right, explain one thing to me. So how the heck do the how the heck do you have the Mega and the Duke connecting to an Ethernet shield right now without the Ethernet without the how do they connect to Ethernet switch without an Ethernet shield and Ethernet cables?
Because I have one.
Oh, where'd you get that one from?
His computer problem.
My computer. Where else?
Damn, Dave, you're really running on Wi-Fi now, huh?
Yeah. I mean,
Okay.
I have a Wi-Fi. I mean, that was a project of mine using a Raspberry. Anyways, that's not the point. That's not the point. The point is we need those cables.
Okay, what cables do you need?
Ethernet cables to connect the Arduinos and the Odroid to the together via the switch.
Do they need to be crossover cables or regular cables are fine?
Regular cables.
All right, cool. With your Ethernet module. All right, boss. I don't know why it's not here yet, but like I couldn't find your module anywhere else. So we ordered it from like some site called like what is it called? Robot Shop.
Oh. Okay. No, hey, don't blame me, man. I'm just asking.
No, I'm not. Is this okay? Is there? Do you just can any generic Ethernet shield or module work?
So from Matt, okay, let me just give you a list of what I got from Matt, right? So I got one Arduino Duo from Matt, 2 Ethernet shields, a USB hub, that's USB 3.0, and some of the power adapters just to power the hub, the switch, and the Odroid.
What do you mean a shield? Do you mean like a shield that you could physically put on top of the Arduino?
Yes.
And which Arduino is this for? The Duo?
No, I fit the Ethernet shield on top of the Mega as well. Because we needed yeah. So the Mega that you provided with us, we just used it to connect it with the Dew, because because of course we need another Arduino to make sure that we can have a network, right?
Yeah.
So we had no choice, but it wouldn't matter anyways, because I think Colin sent me the code for that sensor to download into the Arduino, so I can just download it and just test it from here. So it's not a big deal.
Do you mind sending a picture of how that Ethernet shield looks? Because I don't think it's a shield. I think it's a module.
It says Ethernet shield in the bottom.
Is it the Ethernet Shield 2 or 1?
It doesn't say.
Do you want to send a picture of it, man?
Yeah.
Because like normally shields are Arduino specific, so if it goes on a Dew, it wouldn't fit on a Mega.
Okay, it's just okay. It's an Ethernet shield with the pins. You just put it on top of the on top of you just fit it on the Arduino receivers. Let me just send a picture here.
Yeah, another thing is like with the PCBs, the Arduino's going on the PCB, so you can't really like have a shield on the Arduino. The Arduino is just gonna fit onto the PCB, and like the top of it will be connecting, and all the pins will be connected to the PCB.
Okay, so how do we connect the shields? Or how do we get?
Whoa. You could put the Arduino, or you're putting the Arduino onto a PCB, right?
Yeah.
And there's connectors. Can they not be connected in parallel? You can still connect stuff on top of the shield after that, no?
That's only if the shield has the same outline as the Arduino, right?
Yeah, that's true.
Armelo,
But you put
I'm gonna PM you the on Teams the picture.
Okay, cool.
Wait, just to clarify something. So right now the PCBs are designed as shields. You know what I'm saying?
I know what you mean, Orest. I'm not sure. Is that how you guys designed it?
Okay. Wait, so let me see what I think is gonna happen. I think the PCB is a flat board where I put the Arduino upside down on, so then all the female pins are connected to the male connectors on the PCB. Or is it the other way around? Like
Yeah, so it's like a shield. The PCB is essentially a shield for it.
Yes.
Yeah, okay,
Yes.
yeah.
So, but it's really compact, right? It looks exactly like a shield in a way. You know what I'm saying?
Oh, so it's so tiny that like
It
Oh my
fits
God.
like the Arduino. Like it's the size of an Arduino Duo, and then we put all the components in between the male headers that will go in the Arduino Duo. If need be, then we will try to keep it compact, but if we have to put more components, we will extend the board outside, but still the headers will fit to the Arduino like in the middle or something.
Okay, all right, that works cool, but do you even have enough space to do that while connecting to like a bajillion sensors and connecting to all the power rails?
So the sensors and the power rails will be on top of that, and the headers will be pointed downwards. You know.
Yeah, okay, like my only concern is that you're trying to make it compact, that's cool, but don't make it so compact that it's squished to the level that it's hard to use.
Yeah, for sure.
Yeah, like we have some real estate on the pod, and like the PCBs don't need to be like in a nice orientation. They could be like in obscure orientations and they'll still work.
Yes. So we're going with that right now, and after the revision, we can definitely like extend the board, make it bigger, and it shouldn't be a problem. But yeah, just keep that in mind when you're thinking about it. And this is the thing. This is why like PCB revision will be needed in the end, just so we're all on the same page, right? And we know how everything is going to fit together.
Okay, so let me share my screen. Yeah, like Dave, what you sent me is not what we designed. It's not what we ordered, because it wouldn't really make sense.
Well,
Right.
this is what I got from Matt. So.
Okay, that's what Matt might have done. That's cool, but it's just the way that is. It's that shield will work on most Arduinos, but it's not gonna. It does like it's not gonna like. Is it gonna make it harder for you to plug in the Arduino directly onto the PCB, right? Because like one side you need longer cables for, the other side you don't, or you need to extend the PCB for that,
Right.
right? So what I ordered here was, can I get, yeah, like it's basically like this module,
Right.
and then you have like a couple pins on there,
Right.
and if this guy shows it, yeah, like some of the wires they connect onto this module, which you can do via the PCB, right? And then the an Ethernet thing comes out of here, and then you have Ethernet going wherever the heck you want it to go,
Right.
and your Arduino, whatever it is connected to Ethernet with that.
Right. I mean, it doesn't really matter to us. We just need it just to connect to via Ethernet. That's all. It doesn't matter whether we use this shield or it's the same connection.
Okay, cool.
But no, but the point is that we why I ordered the Ethernet shields was because we needed to like the thing is like without those we can't get we don't have progress. So
What do you mean you don't have progress? Like it didn't work, or
no. What I'm saying is that okay, last semester we couldn't do anything with respect to testing or getting a communication set up because we had nothing to work with. So if we want, the only way we can build a network is if we have the hardware for it. That's it, because
yeah, okay.
we can't just code up a network and say that's definitely going to work. We have to have the hardware and we have to test it and see if it works. So that's why today was so productive, because I shared via my cam the setup, just like a YouTube video would do it overhead. And we all just went through it together. We had live share. I downloaded the code. They see exactly what was happening on two screens. And that's how we were able to get a lot of stuff done. That's why I've been asking, repeatedly, if the shipments come in, because if we don't get those shipments in time, I don't think software will be able to get stuff done on time because we've been waiting a long time for all the hardware.
Okay. Is this the one you have?
The Mega?
No. This is a shield.
Oh wait.
Like the one you sent me, it looks familiar. Like the one you sent, it looks familiar to this.
What's the model H is it? No, it's not the same.
Oh, okay.
I don't know where Matt got this from, but this is what I got from him. So I guess this will suffice to test a network, but it doesn't really matter as long as we can get an Ethernet connection. Even in PCB, whether you have it there, as long as we can just plug in an Ethernet cable in, that's all that matters, right? The only reason I guess what we have this for is that we need these components to actually test it on the Arduinos. So.
Yeah. I agree with Dave in that, like, you should just go get it now, because even if you're gonna wait for the modules and then get the PCBs all wired out, that's gonna take forever.
Yeah, so that's what I'm saying. That's why I ordered the shields, because we don't really care where on the PCB or how. It all that matters is that we have the connection and we can just use it and download the stuff and get it done, test it. But
Okay.
But the big problem that we're having, I'm sorry to keep anyone back, by the way, just let me know, but the big problem we have is that we don't have much hardware. We just have one Arduino Due, a Mega, and one Ethernet cable, and that's it. We need more than that.
Buy things. Like, I've been buying a lot of stuff just to put the batteries together, and like I went through so many weeks of like, oh, I thought I could build it, and then I realized, oh, I need this other tool. Oh, I need this other component, and like I went through like 3-4 weeks of that process.
Yeah, so that's what I'm asking. Like, so with the financing, how does that work?
All right, so I bought some stuff like, I think this was late December or maybe January, just sometime in the winter break, and I still haven't been paid for that.
Still what?
And I still haven't been paid for it, but it doesn't really matter to me because it's not a big amount. It's like less than $100, I think. But the point is, like, there's some issues with getting paid back. So if you buy it yourself, you'll get paid back eventually, but there's issues with it. It'll take a while.
Yeah, the thing is, you see, well, what I'm trying to balance here is if we want to get work done, we need it. So either I risk waiting a long time, in which case I cannot promise you we're going to get anything done. And the thing is that it's not good. And the thing is, if we don't get anything done, it's going to put more pressure on my members because they're the ones who are going to be working day and night for it. So I don't think that's fair to them and myself. So
Like if you don't mind, just like just buy it and then put in the money order to get it back.
Yeah.
Yeah.
And then stuff
That's
that you think you don't need necessarily immediately. When I've put in orders with Arden and I got them like within 2 or 3 days.
Okay, so
Or
okay.
I've even had things come in like 1 or 2 days after. But you need
okay.
to go on the leads all in Teams.
Okay.
And then there's a link there for putting in an order. There's like actually there's this new protocol that he set up. So actually just text Arden. And if he
Yeah,
doesn't
just
follow up, text him again. Just keep texting him.
Yeah.
message him. Like the thing is though, like I ordered like an adapter for like there's some pressure sensor, right? That took like a week and a half to arrive. And on Amazon it literally says it'll come here the next day and it's gonna come here the next day.
Okay, yeah, but
Yeah, it's like
okay, but what about the order that you guys placed for me on November 28th? What?
I don't know. I don't know what's up with that. Because the thing is, I don't have access to actually go and follow with this shit because he places it through MIE, which saves him like tax,
Mhm.
which is great. But like, it leaves us unable to follow up with them, and we have to email them to ask like, what's up with this shit.
Yeah, no, okay, so here's the thing, right? So I DM'd you and you said, oh, message Arden. So during this entire meeting for the past 2 hours, I've been talking to Arden.
Okay.
So he told me that, so this is what he was saying. I didn't want to say it in public. I just want to keep it between us. So he told me that you should have received it. I said, well, I got referred to you, so you can tell me where the order is because I'm pretty sure that they ordered it. And he said, okay. He sent me a list saying this is the orders, but I saw none of the things that I ordered on the list.
All right. So okay. So what I told him to order, right?
Yeah.
Everything here except if it says Home Depot or Creatron or dollar stores, like everything else here, I told him to order. I picked up. I picked up this. I have Ethernet cables. I don't have this module, which is what I'm waiting on.
Oh, and what about the Arduino Dues?
The dues come with the cable, I think, don't they? If they don't, I can buy that too. It's not hard.
Okay, no, I mean the actual Arduino Dues. Like, was that
Oh,
ordered?
I have them. They're like really behind me right now.
Oh, okay. Well, I need.
So like
need-
the main thing I'm waiting on is this module that I told him to order.
Okay, are you using the Dues?
I'm not. So like you can, if you want to come and take it, go ahead and take it. The main thing like that I'm waiting on is this module for you. This Ethernet module. That's really it.
Yeah, so the only thing we need is the Dues, the shields, and the cables. That's it.
This is like your shield or module, whatever. Your
Yeah.
cables like you can get them easily, and then your actual wiring, like I have some lying around, so like you're good with that too.
Okay, so
My main thing is, can you ask Arden for an order put with reference this doc? I'm gonna send you the link to it.
yeah, just the PM me the link.
Yeah, and refer to like this module, like because I remember for a fact I telling you to order this, and this was back in like December or like November time.
Yeah, I didn't see that on the list. He sent me the list. It wasn't there. I don't know what went wrong. But that was weird. Unless they forgot or something. Because I can send you the list that he sent me, and it's
Yeah. What's the list that he sent you? Can you like send it into our Teams?
just you or this.
It doesn't matter. If you send it in the chat, it's gonna send to all electrical, and everyone will have access to it. That's the only thing.
Okay, fine. I'll just send it to you.
Okay, guys.
Yeah,
Normal, do
you
we
can
need
head
to
out.
talk about anything else beyond this? Because I think this is
No,
just between you and Dave.
yeah, like, I can talk with Dave and figure this out. You guys can go. Thanks, guys.
All right, awesome. This is a really productive meeting. We should have. I'm glad we had this.
Yeah, thank you. I'll share the notes too with all electrical.
Yeah, please do that. All right,
Yeah,
see you
sure.
guys.
Okay, cheers, guys. Bye.
All right, take care.
Okay, guys, bye.
Yeah, Ermel, I sent you what he sent me.
Yeah, let me look at this. What the fuck?
Listen, man, I'm just the messenger. I didn't.
Yeah, you're just a messenger. I'm not getting mad at you. It's just that like, I know I filled that shit out.
Yo, I'm as confused as you are. So Because when he sent me this, and I'm like, no, I'm pretty sure they ordered everything that I asked for.
Give me a second. Let me like open up UTHT stuff and then electronics. I'll have to open through drive. Okay.
Yeah, sorry for being late when you guys were asking. So I kind of fell down. So my bad.
No worries, no worries.
Yo, I am sitting on a mess of wires right now.
Okay. Let's go dig into this business bullshit.
So either they forgot, or I have no idea.
I don't know what's up with it, but like I'm just gonna open up the forms he has, cause like you know, like literally, I don't know how this shit works, but it has to be somewhere here because I filled out a form for it.
I mean, their only job is to take the form.
Yeah, exactly. So like
and order
everything goofs
everything
up.
on.
Yeah, like see the receipts I sent are here for some of the stuff I bought. Okay. Responses. Can I go to like where am I? Yeah. Okay.
Okay, let's see.
Electronics. This is stuff I'm buying from Amazon.
I think I have your multimeter.
Yeah, you have the multimeter. That's cool. Don't worry about that. Then this one. Okay.
Let's see. Okay. So.
Oh shit! Did I forget?
Oh my god. Oh my god.
Yo, I swear, I remember I put this shit.
Oh god, what have you done, man?
Oh, I think I know why. Because he asked me to split it up per goddamn provider. He asked to put DigiKey separately,
Oh,
and
but
then RoboShop is a separate thing.
but didn't you put it?
I probably just forgot because like the main ones were DigiKey and Amazon. That's all we ordered from, right? So like, if you see here, Amazon DigiKey, Amazon DigiKey, Amazon DigiKey, Amazon, and then RoboShop.
Okay. All right. Okay. Fine. There's no point in arguing over this. Let's just figure out what we can do. So,
Right.
let me just get back the list. So let's see what we have right now, and I'll just collect that. So the only things we were missing today were more Arduino dues that you're not using, by the way. As long as you're not using them, you can give them to us.
Yeah, take them. Don't worry about that. Take them.
Yeah, just relax, it's fine. So we have the Arduino dues. We need the Ethernet cables, and I have a switch. How many Arduinos are we using in total?
You're only using 3 Arduino dues.
Uh,
The final is only using 3 Arduino dues. The final pod is only that. We have 8 megas that are just lying around for testing purposes.
Okay.
And we have a bunch of nanos for energy systems. But like for the pod, the final production is only 3 dues.
Okay. And all of those are the same wiring with sensors with the diagrams I have access to on the drive, right?
Yep.
Okay, good, because I just wanted to make sure, because the the Ethernet switch that Matt gave me has 8 connections, so I just wanted to make sure. Okay, good. So 1 Arduino, 1 Ethernet per that. So there's the Ethernet cables, the Arduino dues, and the shields. Well, what are we going to do about that?
Okay. All right. So, okay. Do your Arduino dues come with any wire? The ones that Matt gave you, do they come with any wire at all?
No.
Okay. All right. I'm thinking let's just put an order on Amazon, man.
Yeah.
So you get this shit, and then like, sure, we'll get paid later, but like.
Yeah, it's fine. So sorry.
Let's get you started.
Yeah, I'm sorry if I'm frustrating you over this.
No, you're not, man. No worries. Don't worry about it. Okay. Arduino do cables.
By the way, for your Mega, I didn't need any cables for it because
my Mega came with it. I know.
I got that, but the ones that Matt gave me, I had to like dig around in my apartment for like a micro USB.
Yeah. Okay. My only issue with like ordering this, we need to make sure the micro USB support data. right?
Okay, well the one I have was lucky enough to support it. Because
Okay.
it's a micro USB to USB 3.0.
Yeah, so this is like the one right here.
Are you
Okay.
using well whatever ones that you use most likely will support data. So
I don't have like many micro USBs in my house anymore because everything is USB-C, right? Like I think my sister has like an old tablet that's micro USB, but like even that she just uses for the point of it being a tablet, not for like data transfer.
listen, I was lucky enough to find a micro USB.
Yeah, exactly. Like
And
okay.
I still can't remember what I use that has a micro USB, but
All right. Let's just check it. Does this have data?
yeah,
As long as you're
you'll
okay.
this made me realize how disorganized things was last year. Like, man, this is pretty bad. Because no one, he didn't, nobody gave me a micro SD card for that Odroid.
Okay. No worries. That's just kind of life. All right. These are 3 wires. It has
Okay.
a decent rating. It looks like it has cable. I mean, data transfer. So I saw reviews that said it has data transfer. I think this is good enough, and you'll get it tomorrow. I'm pretty sure.
Okay, so let me check. If I have 3 dues,
Yeah, and my main thing is are 3-foot wires long enough for you, or do you need longer wires?
3, 4 wires, oh, 3 feet. Oh no, that's way, 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 way more. I mean, the Arduino on the pod is going to be very close to each other, right?
Um, wait, okay, what are you using these wires for? Tell me that.
To connect the Arduinos and the Odroid, which are going to be on the pod.
Wait, do the Arduinos need to be connected to the Odroid the entire time? I thought the point was them using network cables, so they don't have to do that.
You can have wired or wireless network, but with wireless network, it's more likely that you're going to lose packets of data.
Yeah, no, but like, that's the point of having Ethernet? Ethernet connects them, right?
Wired Ethernet.
Yeah, wired Ethernet. So this is a micro USB. This is for programming the Arduino dues.
Yep.
That's it, right? Only programming the dues.
Yes, we need those to program the dues. Yeah.
Okay, so 3-foot wires is for, because remember, programming is not when the pod is running. Programming is just for like uploading code, and then you're good, and then you take out the wire, and you know.
Yeah, we download it into the Arduino. Yeah.
Okay, so then 3-foot wires are enough for that. For Ethernet, you might need longer because that's all over the pod, but for this, 3-foot is enough, right?
That's more than enough.
Okay, cool.
Right. The Ethernet cables are the most important ones.
Yeah, no worries. Here.
Let's see. Here. Now, I'm just checking. How many Ethernet cables will I need for 3 use? So we have. So that's 1, 2, 3, 4. About 4? Yeah, max.
How long do your Ethernet cables need to be?
It's going to be on the pod, so it doesn't have to be long.
Well, let's try to keep them a bit longer, just so we have like leeway to do stuff if possible, right?
Okay, so what's a good I don't know.
I think like 1.5 meters should or like 2 meters should be enough.
It's 2 meters, so that's about what, 4 feet?
That's like 6 feet. 2 meters is 6 feet.
Oh, sorry, I'm just gonna bring one here.
Yeah, like that's probably taller than you, and I'm hoping that's the width of the pod. So like
2 meters, 6 feet. Okay. Yeah, we can get some one of those things and just wrap it up, just to put it inside the pod.
Yeah. These are kind of. Do they not have like just cheaper cables, like 5 or 6 cables I can just buy together?
Does anywhere sell like batches?
If you can't get it from here, then like I was just thinking, let's go to like some random store like nearby and just buy from there, because they probably have like cables at work and nobody's ever gonna buy them from them, but like they'll get it from cheap, you know.
Let's go to Costco. I don't know.
No, like wait, let's see. The reviews are too low. All right, you know what? All right, we gotta figure out Ethernet cables.
I hope you don't mind me using your Mega for that.
Yeah, go ahead. The megas were bought for testing purposes.
Okay, great.
All right.
So let's solve this Ethernet shield thing.
Yeah, wait. So your dual cables are handled. You need to get your Ethernet module and Ethernet cables. The cables you can buy from wherever the hell you want to buy them from.
Okay, yeah, that's fine. The
Now, so
the shields, on the other hand, so the difference between what we're using now in the PCB, I mean, it's the same as long as it's the same functionality, doesn't matter. But
it's not about, for us, we don't care which one you use. It's just about, can you use the same one, right? Because if you use the same, then it's easier for us to build PCBs because you can use the same schematic. It's easier for like debugging purposes too because you have backups, right? You can change them now and stuff like that, and
Yeah.
the same code works.
As long for us, as long as it connects to the Arduino and we can plug an Ethernet cable to it and to somewhere else, we're good. We just somehow need to fit an Ethernet cable onto an Arduino. That's it. But for testing purposes, we'll just need to test it out, as I said, just to connect an Ethernet. For testing purposes, just the easiest way to connect an Ethernet cable to an Arduino.
It's just any sort of shield, or you can do some data. You can do some wire splicing, but I'd prefer not to do that.
I prefer not. The one I sent you, I believe that can work. So yeah, I just have to just stick the pins on in the correct place, like I did. I have to be very careful when taking them out because some of the pins were bent when I got it.
Yeah, that happens.
I had no idea your temperature sensors were so long.
Yeah, they're huge. It's
But
yeah.
why? Wait, well, why do you need it so big though?
It's not. I didn't even choose this. Half of these sensors, they weren't chosen by me. They were just kind of bought. Like some of them are over spec to the point where, like Kiki and I have talked about, like if you could exchange it for something that's like better our spec, we'll get better precision with our data because the output range, the input ranges will be lower.
The range for these thermometers is between -40 and 300 Fahrenheit.
Like the thermometers is fine, but like let's say we have like a DC current sensor, right? The maximum current it could take is up to 500, right?
Okay.
So the output range that they give us in terms of like voltage is the same, but because it's measuring from 0 to 500, like your precision is a lot less, right? When our output is the max is gonna go to is I think like 150, right? So if you get something within that range, then your precision is better. So you can like you're scaling essentially.
Right. Okay, so I'm guessing these are already tested, so we can just use them. Yeah, yes. I'm just curious, how is this going to be used?
How is what going to be used?
This temperature sensor.
Oh, didn't like he didn't Colin give it to you all connected, or how did he give it to you?
No. He gave it to me in parts, but he sent me the documents on how to wire it.
Okay, yeah. Then
So
you connect one to the other, you screw stuff in, and then at the end you'll be left with like a really long wire, and that wire has like openings, and then you connect them.
I know he gave me a breadboard with the wires and a few resistors.
Yeah.
So just to control the current flow. But yeah, I have a bunch of wires. I have wires here too, so it didn't really matter. But it's a good thing he gave me the resistors in case I need more. But I know I was just what I was asking is, with the temperature sensor so long, where are they going to put this?
Oh, it's going about the front wheel, the back wheel, and in the middle of the pod. Don't worry about the location stuff. Like they kind of already dealt with that.
Oh no, I'm just curious. Oh yeah, Max is on electronics, right?
Yep, he's in charge of like locations and stuff.
Yeah, so I was just talking to him about the placements on the pod. Where exactly are these sensors going? Because I think in one of the last document in December, they talked about, I mean, EHW used some weird terminology. They talked about virtual realization of the pod. So we interpreted that as we are able to see like like a two-dimensional view of the pod and what's working on it. So we're saying we can take each sensor, and because you guys know where it is on the pod, we can have a 2D map, and we can
like so it's not worth you guys to do that because the mech team has a CAD of the pod that has all the sensors. So it'd
Yeah.
be easier for them to just like take a screenshot of that CAD and then for us to use it rather than us to create one from scratch.
No, I'm not saying to create. I just asked him like who has it,
Yeah.
and they can just give it to me. So because in order to respond to one of the requirements in the document, because they use some weird terminology, so the infrastructure lead and I just come to the conclusion that they just want to see where the sensors are on the pod and if we can track it. That's it.
Yeah.
So like one sensor goes down, and from the front end, we'll be able to see that that sensor went down.
Yeah, I get what you're trying to say. Okay. You know what? This doesn't seem to be giving us a reliable enough source. Amazon is kind of useless with this. It seems like. Okay. You know what? Let's check DigiKey.
Okay, so we'll have to order it through at Arden.
I'm thinking this is order ourselves.
Okay, fine.
Like we're already kind of late on this, and like let's just get you started. And in terms of like getting paid back, we'll get paid back eventually.
Yeah. It doesn't matter. I don't really care when I'm paid back. It's just as long as there's a process, I can just give the receipt.
Yeah, there is.
Yeah, I don't really care when, to be honest. Okay. Wait, have you seen the Odroid before?
Never. I've seen pictures of it, but like never actually like put my hands on it.
You want to see what it looks like?
Yeah, sure.
Did the Arduino use bigger than it?
What the fuck?
So I tried to download. So the Odroid runs on Ubuntu or
Yeah.
Android. So we're going to use Ubuntu for obvious reasons. I tried to download onto it, and then I realized that last year Matt never told us that we needed, or I don't know if you read about it, that you needed a micro SD card to download the OS image on it, and then you have to take a card and put it in the Odroid to load the operating system on the Odroid.
Yeah, I didn't realize that. That's sort of like how Raspberry Pi works.
So I was asking like, what was the difference between this and a Raspberry Pi?
Yeah.
And we looked at Waterloo's design, and they use 4 Raspberry Pis as master controls.
It's okay. We already bought it.
Okay.
At least this way, it's easier for you to like just have one master computer. That's because it has a decent amount of RAM. It's decently powerful.
It has 2. I think it has 8 cores, 2 processors.
How much RAM does it have?
Wait, let me get the specs.
Yeah, go take a look.
It says it has it contains quad-core ARM Cortex-A15 and quad-core. It has two ARM Cortex processors, A15 and A7.
Oh damn.
And the RAM 2 gigabytes.
Okay. I guess optimize your code, but that's not that bad. Like
2 gigabytes of memory. 32-bit 2-lane interface, 750 megahertz clock. 1500 megahertz of 64-bit data transfer. Okay, so we can use an eMMC module socket or a micro SD card slot. The eMMC is 7 times faster than the micro SD, so maybe I should get the eMMC. Interesting.
oh my god, what do they think they are? $50 per thing.
Wait, I'm just curious. Who bought all of these shields last year?
I don't know. It was either Rowick or Matt. I didn't make any purchase like other than like testing equipment to actually test out stuff. I haven't done anything like that. Like
Well, no one told me anything about anything, so I don't know. Okay. Because I was under the impression that they already knew how the Odroid worked, but now I realize that they didn't.
they didn't know shit.
So now I'm starting to freak out, and I'm like, wait. So I'm put on a spot where I have to do everything in 2 months.
Not really, man. Okay, like I'll be honest with you here. Okay, you have a computer that's pretty small. I'd be more stressed out about the communication stuff, right?
Yeah.
But like most of it, like is this a putting in the man hours? Like our controls, this inverter basically does everything for you.
Yep.
Like it's like, what are you really doing? We're just gotta connect it all together.
Yeah. No, the control still has work to do. A fair amount of work to do. I wouldn't say that they have nothing to do. They have a lot of work to do.
It's the man hours though. It's not specifically okay like dealing with like actually having to do much control itself, because that job is taken over by the inverter. I'd be a bit stressed out for infrastructure and comms, but like if you've done like networking experience with like sockets and whatnot, I think you'll be fine with this.
It'll be fine. It's just a matter of testing. Let's see here.
Okay, so I found something that's like, I think this will work, but like it has like not that many reviews, but like it'll come pretty close, pretty like easily on a timely basis.
Okay.
All right, so you know what? Yeah, let's open them up. All right.
Let's see.
Okay, we got this one. It can come tomorrow. It's only costs $12, but it only has one rating.
Uh-huh.
So that's kind of no review. It was just one rating, so that's kind of sus. But
All right.
all right.
I don't know how that's gonna fit. Just by looking at that, I don't know how that's gonna fit onto
So you see these 4 pins here,
right?
like these 10 pins. That's how.
But I'm looking at the Arduino Duo and
No, that's not. It's not gonna go on it. You're gonna use wires and connect it.
oh, that sucks. Okay.
All right, and then you have this one. The other one is also the same as this one, except it's a little bit cheaper, but it takes longer to arrive. Then we have this one, 9 reviews. Okay, some guy didn't get it working. Some people got it working. Yeah. Okay.
Okay. Wait, I think that's the. Let me have a look at that. That is very similar to what I have, right? Well, it's similar, but no, it's kind of different.
Yeah, no, it has to have the exact same pin layout. That's the thing.
Okay, so maybe I should just look up what type of shield is compatible with Arduino Duo and Mega.
Maybe don't look at that. Maybe can you figure out like which one do you have, and maybe I can just buy 2 more of those.
I sent you the box, right?
Yeah, you did, but like there's no model number or anything on that.
It's HST.
Wait, HST.
Yeah, I'm just put on my flashlight here. It's kind of dark. So it's HST-004 SAR.
-004
AR. Ethernet shield. HST.
HST 004 SAR.
0041 SAR. I'm sorry.
So this. Yep, okay. Somebody has that. But I don't know where they bought it from. Alibaba. Yo, where the heck did Matt buy all this shit from? In all honesty,
I
actually,
don't know.
wait.
I don't
Right.
know.
Let's look at like all of the receipts because I'm assuming Matt bought this, right? And if you guys figure out where he bought it from, we could probably just go and buy it again.
Listen, last year, I don't know what the hell they were doing. Okay, let's see.
Creatron, he bought power supply and he bought 2 Arduino duos. Okay. And this is some magnets by the looks of it.
Someone spent $100 on magnets. Okay.
Oh no, this is one. Is there any like matte? Yes.
Let's see.
Okay, that one makes sense. Oh, there's multiple pages. Oh, they're all the same thing.
Okay, so that's the shield.
Wait, where is the shield?
No, I'm looking for the shield.
Yeah. If you find the shield here, let me know, because then we'll just order from the same spot he ordered it. Oh, I found it.
Oh, look, it's right here.
If you ordered off Amazon. Oh my god. It's not on Amazon anymore.
Wait.
Whatever.
Go back on the receipt. Just copy that that description there.
Like this thing called 2. Wait.
This Seed Studio, whatever.
No, that doesn't matter. I know which one it is now.
Oh.
There's a code, the W thingy. Ethernet shield. So if I just buy 2 more of these, then we'll get the exact ones you have.
Yeah.
All right. Yeah. DigiKey has this one. Mouser has this one. Okay, that's in the US. No. Right. Does this look familiar with your one?
Mine is just no, it's different.
I don't get where like he got your one, because like
I don't know.
let's look at the pinout. Like
Okay, let me see if I can get anything else that'll help you. It's
I think I found it.
Oh, okay.
Is this
Yeah. That's it. Let me have a look at it. Yeah.
It's also $80.
Oh my god.
It takes forever to arrive. Yep. Okay. Well, we know for a fact that any of these boards are actually gonna work. So if you just find, I think like this DigiKey one, like
as long as it can fit.
Yeah, that's the point, right? That's the point. Like as long as it can fit, it doesn't matter.
As long as it fits and it works and I can test it, that's all. We don't give a shit.
Yeah, okay, there's 5 up here and then there's 8.
Okay, let me see.
Yeah, your thing is similar too. Your thing's like that. There's 8. Yeah.
Let me see. 1, 2, 3, 4, 5, 6, 7, 8. So you got 8 and 1, 2, 3, 6. 8 and 6.
Yeah.
Okay, cool.
Yeah, so that's good. So I think this is like it works, honestly.
Yeah.
DigiKey is pretty reliable. Let's check this out. Let's check Mouser. You can get it. No, we need it earlier than the 18th. Okay. So, each one is $30. How much did Matt spend on it? Actually, hey, he spent about $40.
Okay, so this is pretty good. DigiKey. Do they have like a pickup, curbside, anything? I can just go quickly and get it.
They're like the Amazon for electronics.
Oh shit.
Yeah, you gotta like order them online and stuff.
Okay.
Like, usually they deliver pretty fast.
Okay.
Okay, you know what I'll say? Order 3 of these. Okay.
Yeah. One for every Arduino.
Yep. Okay. So the first link, order 1 of those. The second link, order 3 of these. Before you order, try checking like the shipping time.
Okay.
Okay, like how long it takes. If it takes too long, like just message me. I'll try finding another one, or just look for another one for this W5500 thing.
Okay.
we're just gonna try looking for that, and then for the Ethernet shields, honestly, I think we just gotta go to some place that's open near us and just buy a couple Ethernet shields. I mean Ethernet cables.
I live close to Best Buy, so it's not a big deal.
Okay, cool.
I guess, yeah, I think that's it. Cables, shield, Arduino news. We're done. We're good.
Yep. All right, man. Honestly, my bad for that. I was waiting on the robo thing arriving for like so long. I messaged Arden a couple times about it too.
Yeah,
I didn't realize that like I just goofed up. My bad.
that's fine. As long as I can get it by next week Saturday, I'm good. That's the most important because once the team comes together, we start working. Well, as I said, that session with the breakout rooms was really productive.
I can imagine it being because like you're just grinding stuff out. You know what I'm trying to say?
Yeah, and the thing is, like, I have a GoPro, so I
Oh
have.
shit! So it's like nice.
Yeah, my cousin's a photographer, so like he has like all the latest shit, but he doesn't use one of his GoPro. So I said, "Can I borrow it?" So he just gave it to me. So I have two cameras set up. They can look at me and they can look at the GoPro on a desk, and they have all this. So we have it's like a YouTube channel essentially. I have an overhead stand, so overhead GoPro. You see my hands, you see all the equipment, me connecting it together, and side by side with another screen, you see like my screen share of live of Arduino IDE. I just downloaded, and you can see exactly what's happening side to side. And so basically, we have live share where all the members just code on one document, and then whenever it's done, I just take it.
Fair enough, man. Yeah, honestly, good. Like, I like that. Like, it sounds good. It seems to be working. Right now, my members, they all just have their own sensor, and I just let them like debug and deal with it on their own time, and then they message me whenever they have issues, and I get back to them.
Yeah, that's not going to work for us because our work is so interconnected. So
Yeah, no, exactly. Like for us, I can just tell each person, do this sensor,
yeah,
and they can just kind of deal with it like at their own time whenever they're free, and it's
Right.
kind of independent. With you guys, it's not so much because it's just everyone's trying to test out on the same.
It's a lot of teamwork. So the thing is with the communication is like they're doing a lot of the control and communications are working together because controls have to figure out how they're going to iterate over all of these channels, and then communications are going to figure out how they're going to get all these channels in sync. Because you have data structures where the Arduinos are publishing and updating it, but then the Odroid is reading it. So you don't want to have race conditions where you're getting corrupted data. So then we'll have to use some sort of synchronization threading, where you want to
Yep.
make sure that only one particular piece of hardware accesses that one structure. So so that's why I have the break. So I created the break rooms on Zoom, and Zoom allows you to have break rooms where they can move across break rooms. So they can choose to go in whatever break room that they want, and they can see who's there.
Yep.
So it's just like a real world. It's as if we're in my hall, to be honest.
Yeah, and you walked from one person to the other person, and you're just doing work.
Yep. So so that's why I hated Teams, and I moved everything to Zoom now. So I'm gonna post
Do whatever works for you, man. Honestly.
I'm gonna post a recurrent Zoom link. I don't know where to post it because I don't want it just any on everybody. So like I know electronics and energy system may have some questions. If you guys do,
Post it in all electrical.
Yeah.
And then like I think that's fine. To be honest, nobody really is like everyone here is a part of UTHT. So maybe if like some breaking guy joins your thing, he has a couple questions. Like, I think it probably helps out that we answer his questions.
Yeah.
You
So
know?
I'm just gonna post it, and if anyone wants to come in Saturday 12 to 2 just to see or get an idea of what's going on, just hop in and do whatever you want.
All right, man. Yeah, that sounds great. Okay.
I just realized all of this was recorded.
The recording gets deleted in 30 days.
Okay, let's just hope no one.
I don't think anyone's gonna go through it, but whatever.
Okay. I'm gonna head out. So just send me the links and I'll just.
Yeah, I sent you the links. With the Internet Shield, if DigiKey says it's gonna take too long, I'll message me again and I'll figure out something else to do.
Okay, no problem. Take care, man. Thanks.
Yeah, you too. Bye.